Hello Math 8 students, this is Utah Middle School Math Project 7.1b, squares, squares, and more squares. I believe that I have compiled multiple lessons, so that is just the first one that we will be going over today, and I'll introduce the others when we get to it. On the dot grid below, there are several squares. Some squares are incomplete, meaning these ones that are all the way down here, where it's just the lines. Those are incomplete. First, I want you to finish drawing the incomplete squares. Well, maybe we'll do that second. First, what I want you to do is find the area of each of these squares. So let's go over some of them together. What is the area of this first one? That's easy. That's an area of 1, right? What's the area of this square here? That's 4. Because if you take a look, you can see that we can fit 1, 2, 3, 4 squares inside. Okay. Other ways that we could have found the area are the side length here has a length of 2. This side length has a length of 2, and based on what we saw in our class last time, 2 times 2, or 2 squared, is 4, which is why we see those 4 boxes there. So the area of this one is 4. You can do the other ones that are lined up very nicely and neatly on the grid. These ones are nice and easy. You can just count the squares. This one might be a little bit more challenging. What is the area of this one? If you already know. Okay. What is it, Siley? It is 2. How did you find that it was 2? A half of a square there, right? And another half. So we can see it broken up. There's a half and a half. Here's a half and a half. And when I take this half and move it over, now we can see a full square, right? So this takes a little bit of composing and decomposing these in order to really see what the area is. But just as Siley said, the area of this square is 2. With that in mind, I think that with a little bit of work, you can compose and decompose some of these other ones. Let's do one more though. What is the area of this square right here? Count it up with your groups, check in with each other, compose and decompose that square if you need to. There should be more talking than this. Check in with your groups. Okay. Now that I have this broken up, you can see the inside we have 1, 2, 3, 4 whole squares, but then we have a half square and a half square, which all together make 1. Another half and half, which together make 1. Half and half. Half and half. So what is the area? 4 plus 1, 2, 3, 4. The area of this whole square is 8 square units. Continue on. You don't have to break up everything into halves. Look at, in the middle I found whole complete squares, so I counted those first. See what whole complete squares you can find, and then decompose what's left and figure out how many whole squares we have. With your groups, I want you to find the area of as many of these squares as you can. If you finish early, then you have those incomplete squares that we mentioned. Can you build squares, turn those incomplete squares, or just that line, can you turn it into a complete square? With your groups, let's see what we can get accomplished in 2 minutes. Ready, set, go. We're going to pause the recording during this time. All right, I've got the answers for some of them up on the board. We left off with the area of 8 here. Check your answer here. This should be an area of 18 square units. We have 12 whole squares and then a bunch of half squares that we composed to make full squares. Here I have an area of 32. 24 full squares. These 2 make another square, those 2 make another whole square, and so on, until I have a total of 32 complete squares. These other ones down here are a little bit different. We have to compose and decompose those separately. Here's how I view this one. You guys see that now? And so the area of this one, we have one whole square in the middle, and we've got all of these pieces, right? But when I take this piece and rotate it and combine it over here, how many square units does that make? That makes 2 more. And same thing over here. When I combine this piece and this piece together, how many full complete square units does it make? 2 more, right? 1, 2. So how many total? No, count again. 1, 2, 3, 4, and this one whole complete one in the middle. So this one has an area of 5 square units. Let's pause one last time. I have not found the area of these ones. I'm sure you guys did. Find the area of this one. Now that I've kind of given you some help with this one here, find the area and again, use the time to complete these squares. We've got just a line. Turn these lines into perfect squares. What is that going to look like with your groups? 60 more seconds. Ready, set, go. All right, areas of these remaining boxes, 9, 16, 25. The area of this one, there was 12 whole squares. We have a triangle and another triangle that when combined together will form 2 full complete squares. So that's another 2, another 2, another 2, and another 2 for a grand total of an area of 20 square units. Now making squares here is really not too difficult, but there is a certain thing that you need to understand in order to be successful. Look at this line right here. First thing, how long is this line? 6 long. So how long is it going to be when I draw the other side of that square? 6. What direction is that line going to have to go? This one is going straight up and down, right? What is going to have to happen here? Can I please have your attention? You guys are distracted and not able to answer this simple question, so please focus on what I'm trying to teach you. Thank you. Great connection, exactly what I'm trying to demonstrate. This is a vertical line that rises 6. This needs to be a horizontal line that runs 6. So when I am completing this square, making that connection to slope is really key to being successful on the other ones that are not quite so obvious. Each of these have a length of 6. So 6 times 6, or 6 squared, means the area here is 36. What is that going to look like here? How exactly should this line look? Think about the connection that we just made. This had a rise of 6 and this had a run of 6. What is going to happen? How do I complete that square? Talk with your groups, please, because I don't see any hands, and there should be lots of hands, so talk with your groups. Okay, and now come back to me. What is this going to look like? Daxton? This does have a rise of 1 and a run of 2, yes. So what is this line going to look like that connects it? Is it going to also have a rise of 1 and a run of 2? Is that going to form a square if I do that? No. But you're onto something. Recognizing the rise and run is helpful. How do I change it though? Sam? Rise 2 and run 1. So I'm going to fall 2 instead of rising, right? Rise 2, rise -2, and fall, run 1. Is that forming a square now? Okay, so let's summarize. Here we had a rise of 1, a run of 2. Here we had a rise of -2 and a run of 1. This is easy. I could just create a line parallel. Notice when I create that line parallel, what does it do? It also rises 1 and runs 2. And so to complete this, we are going to have a rise of 2, a run of -1. And so we are seeing some interesting things here. Now that that square is completed, let's quickly find the area of that one as well. We can see 1 in the middle. I've got that same sort of triangle that when combined with this triangle is going to give me 2 extra square units. This triangle combined with this triangle will be an extra 2 units. So 1, 2, 3, 4, 5. The same as what we already had. Didn't we have it? Yeah, this one right here. But the reason why this is helpful is because there are other squares that we could build here that we haven't already built. For the sake of time, I do have to move on. On the next sheet of paper, you're going to see a table, and I want you to start filling in that table. When the area was 1, what was the length of the side? Here's our square with area 1. What were the side lengths? 1 and 1. Make those connections to what we did before, right? If the area is 1, and I know that I find the area by squaring the side length, can you take the square root of each side in order to figure out what the side length was? Okay. And of course it could be a -1, but are we really going to have a length of -1? No. So because of the context, since we're dealing with length, we only need to worry about the positive square root. Continue on. Find your square that has an area of 4. Found it. What were those side lengths? 2. Complete this. You're going to notice that pretty soon it switches to the length of the side was 4, so what is the area that goes along with it? I want you to fill out that table as much as you can. Again, check with your groups. Maybe somebody in your group completed different squares than you did. So put your heads together and get that table filled out, pausing the recording as we do that. Ready, set, go. Again, the top part here is pretty easy. When the area was 1, the side length was 1. When the area was 4, the side length was 2. We can easily count all of these ones. This is a little bit harder. When the area was 2, what is the side length? Do you see how the area of 2, the side length is a diagonal? We can't measure that yet. That's going to be one of our very next lessons, actually tomorrow's lesson, where we can actually find the length of that. But right now, we don't know how to measure that. However, we do know that whatever that length is, let's call it S, multiplied by the same length, is going to give me 2. And based on what we did yesterday, we should be able to solve that then, right? 2 is equal to some sort of side length that's squared. How do you undo a square? You take the square root of each side. What is the square root of 2? What number multiplied by itself is 2? Is it a nice number? No. So what do we put? The square root of 2. With that in mind, what is this side length? The square root of 2. Continue on. Here we had our area was 8. Do we know the side length? No. But we can find it out because the area is 8. And I know that the area is the side length multiplied by itself, or the side length squared. I need to undo that square, so I take the square root of each side, and that is how I get, again, is a square root of 8 a nice number? No. So we just put the square root of 8. Continue filling this out and you should have the square root of 18. Not a nice number, so we just keep it the square root of 18. The square root of 32. And now we're working backwards. What if the side length is the square root of 13? I know that the square root of 13 squared is how I find the area. So what is the square root of 13 squared? Just as we saw back here, I undo a square by taking the square root. This square root and this square, they are undone. Is equal to the area. Okay, so what is the square root of 13 squared? Since that all undoes, it's equal to 13. So what is the area? When the side length is a square root of 13, what is the area? 13. What about this one, the square root of 5? The square root of 5 squared means the area is 5. What about when the area is 36? It is 6, great. When the area is 10, square root of 10, not very nice, so square root of 10. 20, the area is 20, so the side length is square root of 20. Fantastic. Now, a few things that we want to address. This becomes very, very simple then. If I know the side length is 11 centimeters, what's the area? The side length squared, or 121. And it works backwards. It works the other way around too. If I know the area is 16, then I simply need to take the square root of 16, which is 4, and I know the side length. Some connections that we just made. A perfect square is created. How did we create this perfect square? and this perfect square. How did I know how to draw that line? I'm going to summarize what we did. Somebody gave me a rise and a run. They said we went up, I forgot already, up 2 and over 1. And then in order for us to complete that, instead of going just, oh sorry, it was up 1 over 2. I got it backwards. I apologize. It was up 1 over 2. But how did we finish that square? What was the slope of that line that we drew? Sam? We had to reverse it, yes. But it wasn't just 2 over 1. It was negative 2 over 1. So that's a great connection to make. A very important topic that you are going to discuss again next year. We call these, notice what's happening. Where did the 2 go? Where did the 1 go? And that's not the only thing. We also had a negative. So the slopes are opposite reciprocals. That's how we can create that perfect square, when the slopes are opposite. Opposite meaning, if it was positive, the opposite of that is negative. And if it was negative, the opposite of that would be positive. Opposite reciprocals. And of course, summarizing this then, to find the area of a square, when I give you the side length, you simply square the side length. The side length squared is equal to the area. And to work in reverse order, if I give you the area, how can we find that side length? We take the square root of the area. So the side length is equal to the square root of the area. So square roots are going to be a big deal today. Quickly practice, get as many of these done as you can. Try and do them without your calculator. See how good you are with these perfect squares, because all of them are perfect squares. What number when multiplied by itself gives me 36? That would be 6. What number when multiplied by itself gives me 121? Good. See how many you can do? I am not so good at this one. I want to say it's 25. Is it 25? Okay. What is this one? Without using your calculators, what is it going to be? Yeah, we know that the square root of 25 is 5, but we've got these extra zeros, which happen with 50. And the last one, square root of 225, Daxton. 15, great. With all that in mind, are you always going to be given nice square roots? No, as we already saw here. So we need a way to simplify square roots. And this is where we get to 7.1c. This is squares, squares, and more squares continued. This is all about simplifying some of those not so nice square roots. So back to this square, we've seen it before. What is the area of this squared? You guys see it? This one here. What's the area of the square? It's 2. So what is the length of the side? Try again. What number multiplied by itself is 2? Yeah, the square root of 2. Remember how we just wrote that down? If I give you the area, how do I use the area to find the side length? We take the square root. So what is the side length here? The square root of 2. Is that a nice number? No. So we leave it the square root of 2. Now, let's look at A. A, as you can see, has an area of 8 square units. So 8 square units. You can count them up if you needed to, but we already found that on a previous on the front page. So this has an area of 8 square units. However, what is the area of one of the smaller squares? So do you see how it's kind of subdivided here? So what is the area here? 2, 2, 2, and 2. What does that really mean then? Well, here, let's fill that in. What is the area of one of the smaller squares? It's 2. So what is the length of that side length? I'm going to group this together. Oh, it's going to make me move it first. Now I'll group it together. What is that length, that side length of that, just that short piece that goes from here to here? It's the square root of 2, exactly. So what is this length? the square root of 2. So altogether, what is the length of this side? I have a square root of 2 and I have a second square root of 2. How am I going to write that? Couple of hands, talk with your group, see if you can form, use some connections to some previous math. Okay, what is the length of it? What are your thoughts? Emery? It is not the square root of 4. Good guess. It is not the square root of 4. Do you see how we have a square root of 2 and another square root of 2? Okay, so the square root of 2 plus the square root of 2. You might be tempted to say that that's a square root of 4. Okay, is it the square root of 2 squared though? Squaring, exponents are a shortcut for repeated multiplication. Is this repeated multiplication? No. Okay, let's simplify it. I have a cat and another cat. What do I have? 2 cats. I have a square root and another square root. What do I have? 2 square roots. Math practice 7. That's the structure. Something plus something is 2 somethings. So the square root of 2 plus the square root of 2 is 2 square roots of 2. So we had the square root of 2 here. And we just said that this side length is 2 square roots of 2, right? Okay, now let's look at this from a different perspective. Remind me, what is the area of this square here? 8, okay. So the area of this square is 8. I don't want you to talk about the square root of 2. Let's go back to the beginning. If the area is 8, can I find the side length? Yeah, let's go back here. We had an area of 8. What was the side length when we filled out the table? Square root of 8. Because if I know the area, how do I find the side length? We take the square root. All right, so this is an area of 8. So if I want to find the side length, I simply take the square root, and that gives me the square root of 8. Interesting, because it says to write it 2 different ways. One way that we can write it is the square root of 8, but isn't it also true that it's 2 square roots of 2? Yeah, so these are equivalent. They may not look it, but they are equivalent. One is a simplified square root, and one is a non-simplified square root. Let's see if we can make some more connections. Let's move on to this next square. This next square has an area of 32 square units. So let's go the easy way. If the area is 32 square units, what's the side length? Square root of 32. Yes. Okay. Now, let's back up. What is the area of one of the smaller squares? Do you see how we've got all of these smaller squares here? Do you see that? Okay. With that in mind, what's another way that I could write that side length? We already know it's a square root of 32. What else could it be? What is one of these little tiny square root, or one of these little tiny side lengths? Square root of 2, right? How many of those do I have? 4. So a cat plus a cat plus a cat plus a cat is 4 cats. A square root of 2 plus a square root of 2 plus a square root of 2 plus a square root of 2 is 4 square roots of 2. It says to write it 3 different ways. We're going to stop and just write it those 2 because this is fully simplified. Once again, even though they look very different, these are equivalent. So, how do we do this without having to draw squares and without having to draw the smaller squares that are part of it and figure all of that out? That's when we move on to the next section. So this is all the background so that we can actually get to how we simplify square roots. In this section, this is 7.1d, actually simplifying square roots. In this section, we will learn 2 strategies for simplifying square roots of numbers that are not perfect squares. Both strategies are really doing the same thing. The methods are just a little bit different. So what does it mean to simplify a square root of a non-perfect square? These are some examples. Square root of 8 is equal to 2 square roots of 2. I skipped this one. There was another example, but I skipped it. The square root of 32 is equal to 4 square roots of 2. What do you notice? Turn and tell your groups, what do you notice about the simplified and the non-simplified? Talk with your groups. I'm going to pause the recording. Okay. What are the factors of 8? What numbers can I multiply to give me 8? Danielle. 2, 4, 1, 8. But 8 and 1 are redundant because what are the factors of 8? Back to 2 and 4, right? Okay, the factors of 8 are 2 and 4. Just keep that in mind. What are the factors of 32? 4 and 8, yes. That works. 2 and 16. Okay, keep that in mind. Here's what I want you to notice about this. The factors of 8 are 2 and 4, yes? Okay. Is 2 a perfect square? No. If I try and take the square root of 2, it's an ugly number. Is 4 a perfect square? Yeah, it is. That makes me happy. Is, looking at the factors of 32, even though this is correct, I want to focus on this one. Is 2 a perfect square? No. Is 16 a perfect square? Okay. Can you make some more connections to what you see here? Look at the square root of 8. You said that the factors are 2 and 4, and 2 is definitely not a perfect square, right? Which is why it still is an ugly number and it stays inside the radical. Square root of 2. 32, we have 4 square roots of 2, and again, 2, not a nice number, so it stays in the radical. What do you notice about these purple numbers? Purple number, and here. Purple number, and here. Turn and talk to your groups. What do you notice? What is the square root of 4? The square root of 4 is 2. What is the square root of 16? 4. So what do you see? And what do you see? That's the hint. We are out of time, so this lesson is going to have to continue tomorrow when we go over the strategies. That is it for today. Thanks for watching. We'll see you next time.